విజిబుల్ అవుతుందా అన్న ఇప్పుడు? నాన్న విజిబుల్ వస్తుందా? హలో హలో హలో
లేదు మేడం.
ఇప్పుడు కాలేదా? మీరు అందుకే మీరు లైన్ లో ఉండండి. నేను అందుకే మిమ్మల్ని లైన్ లో ఉండనమ్మా అంటున్నాను. నేను ఒక్క నిమిషం నేను అది విజిబుల్ నానా కనబడుతుందమ్మా? పీపీటీ కనబడుతుందా? పీపీటీ కనబడుతుందా?
లేదు మేడం. లేదు
లైన్ లో ఉండండి నాన్న, ఒక్క నిమిషం లైన్ లో ఉండండి. అందుకే మిమ్మల్ని ఒక 10 minutes ముందు రమ్మని చెప్పాను. ఇప్పుడు నానా, ఇప్పుడు హలో సాత్విక, ఇప్పుడు కనపడుతుందా
లేదు మేడం?
నానా? ఇప్పుడు ఇప్పుడు
లేదు మేడం. లేదు మేడం.
చూడండి, ఇప్పుడు చూడండి, ఇప్పుడు చూడండి, కనపడుతుంది. ఇప్పుడు
లేదు మేడం.
లేదు. కనిపిస్తుంది మేడం.
కనిపిస్తుందా? ఒక్కసారి సైడ్కి పోండి, మీకు కనపడుతుందా? ఓకే
మేడం.
ఓకే, కనపడుతుందమ్మా?
ఎస్ మేడం.
ఓకే. So good morning everyone. In the last class we discussed about what are the different types of the elements and what are the different terminologies. That means what is node, what is branch, and what are the different voltage, current and the remaining terms power, energy, and what are the different types of elements. Under this we have discussed about the active elements and passive elements. Under the active elements and passive elements we discuss about the voltage sources and current sources, and the passive elements we discuss about the resistor, inductor, and capacitor. So about that there are the in the first unit there are, it will be two parts, electrical circuits and magnetic circuits. Under that electric circuit we discuss about the circuit concept and what are the different types of the elements and the sources, and up to now voltage current relationship, what is the voltage relationship and current relationship for passive elements for resistor, inductor, and capacitor. And today we discuss about the what is relation Kirchhoff's laws and what are the network reduction techniques. So these are some of the we already discussed about the what is the circuit. It is a closed path followed by an electric current. That means that is the combination of the both active and the passive elements is nothing but the electrical circuits. Under this we discuss about the what is the node and the branch. Node means it is the connection of two or more elements meet at one point, and the branch means it is a line segment joined between the two elements is nothing but the branch. And then we discuss about the what is the charge and what is the current, voltage, and the power and energy. This is the basic circuit concepts. We already discussed what is the active elements and the passive elements. Under the active elements there are the sources must be there. Under the sources we have discussed about dependent sources and independent sources. Under the independent sources we already there is a voltage source and the current source. And the voltage source means what is first what is the active elements are, which delivering the power is nothing but the active elements, which receiving the power is nothing but the passive elements. So under this there is the independent sources. Under the independent sources there is the voltage source and the current source must be there. Source means whatever the current must be there, the voltage will be maintained constant is nothing but the voltage source. That means due to this there is the ideal and practical voltage sources must be there. Under the ideal voltage source, so there is in voltage source, there is the internal resistance must be in the series. So due to that internal resistance, when I am at the time of the ideal, I am telling that I have neglected that resistance. Due to that resistance, there is whatever the current must be there, it will be maintained constant. But as shown in the practical voltage, so due to that internal resistance point of view, there is some of loss of the drop must be there. So that is due to that drop it will be decreased somewhat. So that is called practical voltage source. Under that current source must be there. Under that current source, whatever the voltage must be there, the current will be maintained constant. Under that there is the ideal current source and practical current source must be there. Under this ideal current source, what ideal current source means, the current source, the resistance is always in parallel combination. So I have neglected that resistance value. For the when I neglect that resistance value, it will become to the constant point of. Under the practical current source, whatever we are not possible to neglect that resistance. Due to that resistance there is a drop. Under the passive elements which receiving the power is nothing but the passive elements. Under the passive elements there are resistor, inductor, and capacitor must be there. What is resistor? Which opposes the flow of current. Resistor is unit will be ohm and the symbol we are using is R, and it dissipates in the form of heat. It's nothing but the resistor. It does not store any energy. And inductor means it is we have used the letter will be L and the unit will be Henry. And what is the behavior of the inductor is which it will be it will be opposes the sudden changes of the current. It opposes the sudden change of current is nothing but the inductor. And the capacitor which opposes the sudden change of voltage is nothing but the capacitor. And the capacitor, it will be used, the letter will be C and the unit will be farad. So basic, this is the active and the passive elements. Active elements means which delivering the power and passive will be receiving the power. These are the different types of elements, that is resistor, capacitor, inductor. Resistor ability to resist the flow of the electric current, and the capacitor it is ability to oppose the change of the voltage across it. Inductor it ability to oppose the change of current flowing through this. That means sudden change of current opposes will be inductor, sudden change of voltage opposes will be capacitor. This is the symbols of resistor, inductor and capacitor. The unit will be ohm, Henry and farad. So these are the under this circuit elements. There are under this sources, active elements, there is the dependent sources and independent sources must be there. Dependent sources is which one source will be dependent upon another. One source will be controlled by another sources, then it is called as the dependent sources. Under this dependent sources, there is a voltage control voltage source, current control voltage source, voltage control current source and current control voltage sources must be there. That means any source will be dependent upon another. It will be controlled by one another sources. It is called as dependent sources. And next one is there is the independent sources, means it does not depend upon any source. It is independent in nature. That means whatever the voltage will be there increases, the current will not be dependent upon that voltage. It will be maintained constant. Independent in nature is nothing but the independent sources. So when you show that there is ideal voltage source and when you observe this figure, so this is ideal voltage source. I am telling that whatever the current in x-axis it is current and y-axis it is voltage. So when whatever the current must be there, the voltage will be maintained constant. That is called as ideal voltage source. So this is about the practical voltage source. When you observe this in the last figure, when you observe here there is no resistance, but I am telling that in voltage source there is internal resistance must be there, but this resistance will be in the series form. So when you observe this figure, there is no resistance because I have neglected that resistance part. So I am neglecting that resistance part, so it will be maintained constant. When you observe this, there is the resistance, practical point of view, there is the internal resistance must be there. Due to that internal resistance, whatever the current must be, there is a little drop of the voltage. In the last, it will be maintained constant, but due to that internal resistance, it is somewhat of the drop of the voltage, so it is called as practical voltage source. Simultaneously, we observe the ideal current source. In this ideal current source, I am telling that x-axis will be voltage and the y-axis will be current. Whatever the voltage must be there, the current will be maintained constant. The current will be maintained constant because it is here, there is no, I am telling that in the current source, the resistance will be, what is the resistance? The resistance will be in the parallel combination of the current source. But when I am telling the ideally, I am neglect that resistance. So when you have to show this practical current source, when you observe that the resistance parallel is nothing but the adjacent, shunt. Series means the same side, parallel will be adjacent form. So when you observe that here the resistance must be there. Due to that resistance, it will be in the parallel combination. So whenever the voltage will be increases, that is n x-axis the voltage increases, generally in ideally it will be maintained constant, but in practically there is a little decreasing of that value because due to that internal resistance, but that internal resistance is always parallel. Due to that internal resistance there is some drop of that current sources. So this is about the, when you understand the difference of the ideal and practical means, ideal means I generally neglect that resistance value. Practical means there is no possible by neglecting that resistance. So it is somewhat will be, there is a little bit of drop must be there. You remember that for voltage source, the resistance will be in the series combination. For current source, the resistance will be always in the parallel combination. And there are some of the another classification of the network elements must be there, that are linear and non-linear element, lumped and distributive element, unilateral and bilateral element, time variant and invariant elements. There is another classification of network elements must be there, that is linear and non-linear element, unilateral and bilateral element, lumped and distributive element, and time variant and invariant element. So what is the linear element? Means it is linear, it's nothing but the same. That means it passes a straight line through the origin. That means according to Ohm's law, we know that voltage is equal to current into V is equal to IR. V is equal to I into R. Voltage is equal to current into resistance. It's nothing but the Ohm's law. Generally, we know that V is equal to IR, that is voltage is proportional to the current. Another classification of the Ohm's law is I is equal to V by R. That means whenever we have to reduce, we have to decrease the resistance value, current will be increases. When you are increasing the resistance value, current will be decreased. It is inversely proportional. Similarly, R is equal to V by I. Similarly, R is equal to V by I. So when you are decreasing the current, resistance will be increases, and when you are increasing the resistance will be decreased. These three laws will be proved by Ohm's law. Ohm's law is equal to V equal to IR, I equal to V by R, and R is equal to V by I. These three laws, due to these three laws, he observed that whenever what current increases, what about the resistance? And whenever the voltage increases, what about the resistance? And whenever the current decreases and voltage increases, what about resistance? See, they have taken as the three values, that is voltage, current and resistance, and they observe that what is the ratio of the voltages, current and resistance. When it will be the one will be increases, what about the another two particles? And when will be decreases, what about the other two particles? Like when it will be zero, what about the other? They have to observe this. Charge Ohm will be observed about what are the three parameters. Like that, when you discuss about the linear circuit means whatever the it is proportional. That means it is a passes a straight line through the origin is nothing but the linear circuit. Otherwise, when it will be the curve, then the changes of any voltage and the current is nothing but the non-linear elements. That means it will be the curve point of view. Then we discuss it is as the non-linear circuit. And next one is bilateral element and unilateral element. When the element direction will be changes, then it will be the direction of the current will be changes. That is, it will be a same in either direction. That means the properties or any characteristics are same in the either direction. If one element changes, then automatically the current direction changes. Then it is called as bilateral element. If suppose the direction does not changes, if one direction will be changed, the element direction will be changed, the direction of the current is not changed, then it is called as unilateral element. When you observe that whose properties are same in either direction, then it is called as bilateral element. Whose properties is changes in the direction of this operation, then it is called as unilateral element. And then there is the distributive element and lumped element. What is lumped and what is distributed element? Lumped element means whose size is small compared to its wavelength. The element size is small compared to its wavelength, depend upon its frequency. It's nothing but the lumped element. That means the element whose direction, the element whose size is small compared to its wavelength. Wavelength is nothing but lambda. Compared to its wavelength, depend upon its frequency. Then a type of elements is called as lumped elements. These are resistors, inductors and capacitors. These are all called lumped element. Otherwise, it is called as distributed element. That means if they compare the size of the element compared to with the wavelength is not less, then it is called as distribution element. That is main long transmission lines is nothing but the distribution elements. So next one is the time variant and invariant elements. What is time variant and what is invariant elements? So what is time variant elements means the element whose time will be vary with respect to time is called time variant element. The element varies does not vary with respect to time is called time invariant element. The element varies with respect to time is nothing but time variant element. The element does not vary with respect to time is nothing but time invariant element. That means another classification of the network elements are four types: linear and non-linear element, unilateral and bilateral element, and lumped and distributive element, and time variant and invariant element. Linear non-linear means it passes a straight line through the origin is nothing but the linear. Otherwise, when it will be the curve, then it is called non-linear element. Next one is lumped and distributive element means the element whose size is small compared to its wavelength depend upon its frequency or lumped elements. Otherwise, it is called as distributive element. Bilateral elements means it with the properties will be same in either direction is nothing but the bilateral element. When it will be changes, then it is called as unilateral element. Time variant elements means the element varies with respect to time is called as time variant element. Otherwise, it is called as time invariant. The element does not varies with respect to time is nothing but time invariant elements. Next, we discuss about the what is the voltage current relationship, VI relationship of the passive elements. Voltage and current relationship of passive elements. Generally, we all know that there is a resistor, inductor, and capacitor must be there. These are the passive elements or the resistor, inductor, and capacitor. So under this, there is what is the VI relationship and voltage and current relationship. What is the relationship? Generally, what is the voltage relationship of the resistor is V is equal to IR. I into R is nothing but the voltage relationship. And what is the current relationship of the resistor is I is equal to V by R. I is equal to V by R. It is the relationship of resistor. Generally, but what is the relationship of inductor is V is equal to L into d by dt. That is differentiation of inductance. The voltage is differentiation of the current is nothing but the voltage relationship of the inductor. And the current relationship I is equal to 1 by L integral of Vt. The current is the integration of the voltage is nothing but the integration of voltage is nothing but the current relationship of inductor. And same thing, what is the capacitance? What is the voltage relationship of capacitance? V is equal to the voltage is the integration of the current is nothing but the voltage relationship of capacitor, and the current is the differentiation of the voltage is nothing but the current relationship of capacitor. That means we observe that resistance voltage is equal to current into V is equal to IR, and current relationship is I is equal to V by R. For inductance, voltage is equal to V is equal to L di by dt, and current relationship I is equal to 1 by L integral of V dt. For the capacitance, voltage relationship is equal to 1 by C integral of I dt, and the current relationship is C dV by dt. But in the resistor, it does not store any type of the energy must be there. Generally, energy is defined as the energy is equal to W. We have mentioned that the integral of the power dt is nothing but the energy. Power, generally we know that power is equal to voltage into current is nothing but the power. Power, how you find out the watts in the power is equal to, power is nothing but watts. Watts is equal to voltage into current is nothing but the power. And what is the energy stored in the inductor is always half Li square. It is half Li square. Simultaneously, the energy stored in the capacitor is half CV square. It is half CV square is the energy stored in the capacitor. This is a voltage relationship of the capacitor. You remember that voltage is equal to current into resistance for resistor. Current is equal to I is equal to V by R. For inductor, V is equal to L di by dt. I is equal to 1 by L integral of V dt. For capacitor, V is equal to 1 by C integral of I dt. And the current I is equal to C dV by dt. And this is a very, very important topic, that is Kirchhoff's laws. So, and what is the under the Kirchhoff's laws? There are generally two types of laws must be there. One is Kirchhoff's current law and another one is Kirchhoff's voltage law. Kirchhoff's current law and another one is Kirchhoff's voltage law. So, first we discuss about the Kirchhoff's voltage law. So, Kirchhoff's voltage law is the algebraic sum of the voltages is equal to 0 is nothing but the Kirchhoff's voltage law. It is called KVL. The algebraic sum of the voltages is equal to 0. It's nothing but Kirchhoff's voltage law. So when you observe this, circuit, that is, when you observe this, here the I is equal to current flowing through the closed path. I is equal to current flowing through the closed path. When you observe this circuit, there is how many resistance must be? 4. That is R1, R2, R3, R4 and R5. 5 resistance must be there. And then how many voltage sources must be there? V1, V2 and V3 and V4. 4 voltage sources must be there. There is, what is Kirchhoff's voltage law? Means the algebraic sum of the voltages is equal to 0. And this Kirchhoff's voltage law, it is also called as mesh analysis. And it is also called as loop analysis. It is also called mesh analysis, or it is also called as loop analysis. The algebraic sum of the voltages is equal to 0. It's nothing but Kirchhoff's voltage law. It is called as mesh analysis, or it is called as loop analysis. When you observe that, first, how you have to write this, why you are using this Kirchhoff's laws to find out the voltages and to find out the currents, we have used this Kirchhoff's laws. That means we have to, for any circuit or any network is used, how much of the voltage is there, how much of the current is there, how much of the power will be there. We have to find out that elements. We have to use these types of laws, not only these types of laws, to reduce the complexity of the any network. We have used Kirchhoff's law, star delta transformation, source transformation, or some of the theorems must be there. To reduce the complexity, we have to use different types of the methods. Under that method, we use this Kirchhoff's law. But this is a very, very important topic. So you have to understand that here, when I'm what is Kirchhoff's voltage law means algebraic sum of the voltages is equal to 0. Is nothing but the Kirchhoff's voltage law. So when you observe this, here there is the resistance and the capacitance. First thing, when you find out this Kirchhoff's voltage law, first thing you have to observe how many loops are there in the circuit. How many loops are there in the circuit. So when you observe how many loops are there in this circuit means, so generally loop means it acts to the same point. Loop means, so suppose I am showing that here the current direction I am showing. That means it will be starts here and return back to the same point. Then it is called as Kirchhoff's law. So loop means that current will be reaches to that same point. Then it is called loop. Suppose the same that part will be, another will be there. Then that is another loop. Like that, there is the 2 loops must be there, 3 loops must be there, and 4 loops. Here there is only 1 loop must be there. It starts at one point and return back to the same point is called as loop. If another circuit, another network is there, there is the second loop. If another will be there, there is the third loop must be there. So when you observe that, here it starts. First you have observed that how many loops are there. Here from this figure we observe that there is only 1 loop are there. Next, second thing, then we have to mention the polarities. Mention the polarities. How you mention these polarities means depend upon the direction. Depend upon the direction of the current. You have to mention this polarity. Depends upon the direction of the current. You have to mention the polarities. So that means for the polarities of the voltage sources, we does not change, because for the long line it will be plus and the short it will be minus. These are the voltage sources. Batteries polarities does not change, but the remaining batteries are active elements which delivering the power, but the resistors are passive elements which receiving the power. The receiving element polarities will be changes. How you change the receiving element polarity? Depend upon the direction. If the current will be like, it will be starts from this point, that means from that point I put as, when it will be entering to the resistor, I put as positive sign. When it will be leaving to the resistor, I put as negative sign. Similarly, when you entering the put as positive, leaving will be negative. Entering positive, leaving negative. No need to they change the voltage sources because their polarities does not changes, but only the change will be the passive elements. So depend upon the passive elements, there is 5 resistors must be there. For this 5 resistor, we observe that the entering will be current will be positive, leaving will be negative. Entering positive, resistor 2 R2 entering is positive, leaving will be negative. For resistor is entering is positive and leaving will be negative. Same thing R4 positive and negative. Positive depend upon the direction when you observe that. But here R5 also, this is positive. For negative here mentioned it will be negative, but it is wrong, it is positive, and the next one is negative. So then we observe that entering of current is positive and so first we observe that how many loops are there. Second, we observe that what are the depend upon the direction, we mention the polarities. But remember that it does not change the polarities of the batteries, polarities of the sources. We have to change only the polarities of the passive elements. If suppose the direction is like this, if suppose the direction will be opposite direction, depending upon the direction we have changes the polarities. Entering is positive, leaving will be minus. Entering is positive, leaving will be minus. And next thing, third thing, when you observe that, then you write the equation. I tell that the algebraic sum of the currents is equal to, sum of the voltages is equal to 0. So for that you have to write that what is the voltage is equal to, generally I am telling that the voltage is equal to current into resistance. Current into resistance is nothing but the voltage according to Ohm's law. So what is the current flowing this? I. And I am coming from this side. So first V1, this is minus downwards and plus is for upwards. That means rise of potential, minus to plus. It comes to the rise of potential. If suppose plus to minus is there, then drop of potential. When it will be the rise of potential, put it as positive sign. When it will be the drop of potential, put it as negative sign. Like that, minus to plus is rise of potential, plus V1, plus V1. Next, plus to minus, drop of potential. It will be plus to minus. So it will be drop the potential. So put it as negative sign, minus. So when you put is the negative sign, then here there is no need to write the generally minus to plus V1 because that is voltage. I am telling that the algebraic sum of the voltages is equal to 0. It is simply voltage. But here the value will be resistor. I am telling that sum of the voltages is equal to 0. So according to Ohm's law, we know that V is equal to IR. So what is the current flowing to this resistor? I. And what is the resistance value of this resistor? R1. So we have to write down that I into R1. I into R1 plus to minus minus I into R1. Next one plus to minus. Same thing, minus I into R2. Next plus to minus. Drop of potential minus V2. Minus V2. Next plus to minus. Minus means drop of potential. I into R3. Next comes to plus to minus. Minus of I into R4. Next here I am telling that this is plus and this is minus. Plus to minus. Minus I into R5. Minus to plus. Plus V. Rise of potential plus V4 is equal to 0. So we starts at V4 and we ends for starts at V1 and we ends for V4. Here when you observe that, we observe that there is the, how you write down the equation is, first you observe that how many loops must be there. Second we observe that how many, write down the polarities. How you mention this polarities means when it will be the rise of depend upon the direction of the current. Entering direction will be plus and the leaving direction will be minus. So depending upon the current direction, you have to put the polarities. And the last thing you have to find out the depending upon the polarities, when there is minus to plus, there is rise of potential, put it as positive sign. When is the drop of potential, that means plus to minus, it will be decreasing form, then you put as negative sign. Sir, for the voltage sources, we need not to be changed the polarities because it is a bad thing, but the resistance value, so we have to change the polarities depends upon the direction. Simply you that if suppose this direction is will be the opposite direction, generally tell that it will be the direction will be opposite, then whatever the positive must be there, it comes to the negative, and whatever the negative must be there, it comes to the positive. If suppose our answer will be in the negative point of view, then we tell that our assumption will be in the opposite direction simply. So this is a very important topic. Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0, and here that we observe that how many loops are there, and first thing, and second thing we have to assume the polarities, and third thing we assume that when there is the rise of potential, put it as positive sign, and when there is a drop of potential, put it as negative sign. This is about the Kirchhoff's voltage law. And same thing, Kirchhoff's current law is there. Kirchhoff's current law, it is also called as nodal analysis. Kirchhoff's current law means the algebraic sum of the currents is equal to 0. Sum of the currents according Ohm's law, I is equal to V by R. It depends upon the total. We have to find out I is equal to V by R. But here Kirchhoff's voltage law, V equal to I into R. So I is equal to V by R. From that, Kirchhoff's current law, the algebraic current is equal to 0, or current entering is equal to current leaving. Current entering is equal to current entering to the node is equal to leaving the node. Because so it is called node means 2 or more points meet at 1 point. So it is totally depends upon the node, so it is called as Kirchhoff nodal analysis. It is totally depend upon the loop, so it is called as loop analysis or mesh analysis. In the Kirchhoff's law, when you observe that this is the black spot will be the node point, here the I2 current and I1 current are entering. So I1 plus I2. What are the leaving currents? I3 and I4. I3 plus I4. So the total sum of the current is I1 plus I2 minus I3 minus I4 is equal to 0. So we observe that Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0. Kirchhoff's current law means the algebraic sum of the currents is equal to 0. So this is about the Kirchhoff's laws. Next class we discuss about the what are the different problems and how you solve this problems in this Kirchhoff's laws. Hello? Hello? Hello, Nana? Anusha,
Yes, madam.
Swati, ಏನನ ಇನ್ನು ಪಡಿಂದ